All right, gang. In the last video, I kind of ripped Rasmussen reports a good one. Let me tell you what. I don't think I left that assessment fairly. I think I know I left their assessment of them fairly, but I don't think I let you know exactly what should have been done. So let's just spend a couple of minutes and go over that. Again, they make a mistake here when they said that 48% of likely U.S. voters, because it's not, it's 48% of the 1,500 who were sampled approve of President Obama's job performance. So what should we do? Well, we should go down here and look at the good stuff. Now, luckily, they do provide something pretty interesting here. So what I would want to do is see that the margin of sampling error for the full sample of 1,500 likely voters is plus or minus 2.5 percentage points. So with 95% confidence. So I'm going to write this down. So the p hat, again, let's make sure that we understand what's going on. P equal the percentage of likely U.S. voters who strongly approve. I think it was strongly approve. Let me make sure I get my my language correct here. Who approve, I'm sorry. Of Obama's job performance. Now, they have used an estimate of 48%, and they said that they had a 1,500 total voters that they put in their sample. So it'd be easy to see that 0.48 times 1,500. That they had, 720 people out of this sample who said that they approve of Obama's job performance. Now, we know that, first of all, we got to kind of buy in, is this a good sample? I don't think it is, but I would feel comfortable using it and softly generalizing from it. So we know that from later on in the article that they say that the margin of error is 0.025. So they've already gone ahead and done the calculations there. So, as a percentage, this is 48% plus or minus 2.5%. So what would we have there? 45.5% up to 50.5%. So we can say that there's a 0.95 probability that this P up here that's unknown, but they are trying to act like they know it, is somewhere between 45.5% and 50.5% with a 0.95 probability, 0.95 level of confidence, okay? All right, I got a handout for you that I want to, if I can find it, I've got, hard to keep everything up to snuff here. Yeah, here it is. Now, I'll tell you what. One thing I want to do before I get into that, let's go back to the previous example. In the other video where P had, and this is the one about the Supreme Court decision on making same-sex marriage legal. And what I said we did, we assumed is that we went out and we got 1,000 people randomly selected, and 581 said that they support the Supreme Court decision. Um, I don't remember. I can probably find it. But I think the margin of error, or I'm sorry, the confidence interval that we got, I remember this now, 55% to 61.2%. And we did this using the formula. Well, guys, there's another way you can use this called a one, or I'm sorry, not use it, calculate this, and this is using your calculator, using a one prop z interval command. It's really, really easy to do on your calculator. If you go to stat, just like we've done before, and scroll over to test, and what you actually find out, the way that this is laid out on your calculator, is there's two techniques in inference, hypothesis testing and confidence intervals. Well, if you see all these first six, they're all tests. But for every test, there's a corresponding interval. So we will learn eventually something called a z-test, a hypothesis test. Now we're doing the corresponding interval, which is a z-interval. If you see the next thing, a t-test, well, right below z-interval, you'll see that we have a t-interval. So for every test that we have up above, we have a corresponding interval. Well, right here, we have a one-prop z-test. Well, the corresponding confidence interval to a one-prop z-test is the one-prop z-interval. So we can come down to the one-prop z-interval, which is right here. And what you enter into the calculator here is very simple. X is just the count. 581. We had 1,000. And we have a 0.95 probability. Okay? You calculate, and you'll see that we get exactly the same thing as we did before. Using the other calculator, the other operating system, let me bring that up. And actually, there may not be any difference in the operating system here now that I think about it. Go to stat, go over to test, come all the way down, I think, to where we have one prop z interval. It's there somewhere. There it is. No, so it's actually the same. So x is, again, the count. So it's 581. N is 1,000. And confidence level is 95. So calculate that, see we get the same thing. Now, one thing that you need to take in consideration here is the way the problem is presented to you. So let's say that we have a situation right here where the count isn't given, but we say the 23.5% of the 1,723 sampled. Now, how would we create a 95% confidence interval here? Well, we could still use our calculator. If we used our formula, it's really easy. We just have 0.235 plus or minus 1.96 square root 0.235 times, what's that going to be, 0.765 over the total sample to 1723. So if we use the full formula, that's easy. It's a little more challenging when you use the calculator, because what we would do is, well, I'll tell you what, let me use this over here. When we go into our confidence interval formula, we have to have the count. Let me show you the way you take care of that. And this will come up on your homework assignment. So I'm going to have to say that 0.235 of the 1723 that were sampled gave me a response that I'm questioning, so that I have a count there. Well, I can't have 404.905 people. So what I would do, I have to make that an integer, so I would make that 405, and then I would have my 1723. So guys, both of these numbers have to be integers in your one prop C interval. So I know what's going to happen. I'm going to get emails and say, Dr. Darbo, my calculator won't work. Because let me show you what happens if you do the 0.235 times 1723. Let's just leave that as a count. Come down 95 and hit calculate. It's going to give us an error. And then you're going to throw your hand in the air and I don't know what I'm doing. I don't even like statistics. It's stupid. Things like that. Things that my daughters would do. So, but you just didn't let me teach you. You went out on your own and tried stupid stuff, goofy stuff. Guys, let me teach you something. I know what I'm doing. So we'd have to change that 404 to the next biggest count. So that would be 405. So we have 405 out of 1723 at 95% confidence. Hit calculate, and life is good. It calculates the confidence interval for us with no craziness. All right, so I'm going to use the calculator anytime I get a chance because it's easier and it's it's efficient, and it doesn't do little crazy things. Sometimes we'll see like 0.68, and for some reason we'll want to put in 0.86. So and we all do it. I certainly do. All right, gang. Let me see if I can sharpen this up a little bit for you guys. A little bit better. So in a CNN poll a few days ago, a random sample of 781 adult Americans was drawn. Of these people, 414 stated they agreed with the recent Supreme Court decision, which legalized same-sex marriage. Guys, the previous video, that 581 out of 1,000, I made that up. I did not make this up. This was something I did find. So, using the data, estimate the proportion of adult Americans who agree with the Supreme Court decision. In other words, what is the value of p hat? Present your answer to as a decimal, rounded to 3 places. All right, so p hat's really easy to find. P hat is just our count, 14 out of 781. So it looks like to me to 2 places. Was it 3 places or 2 places? 3 places. That would be 0.530. Yeah. Now, okay, I'm going to go on. You notice in an internet search that CNN reported that a recent survey shows that 53%, which is what we got up here, of adult Americans agree with the Supreme Court decision to legalize same-sex marriage. Is this an accurate statement based on the random sample of 781 adults? Absolutely not. What they should have said is that 53% of the 781 adult Americans who were surveyed agree with the Supreme Court decision. There is no reason ever to assume that what we got in our sample is going to match up perfectly with what we're trying to estimate from our population. Chances are we're just not that lucky. There are infinitely many of these. There's one of those. Why do we think out of infinitely many choices we're going to get the one that matches up perfectly? Probably not. There's going to be error, and we have to allow for margin for error as we do in confidence intervals. So don't let these people skew you. They've turned my dad into he believes all that stuff. Don't do that. So absolutely not. Again, what they should have said is 53% of the 781 adult Americans who were surveyed agree with the Supreme Court decision. Calculate and interpret the 95% confidence interval. Guys, I tell you what, anytime I have the opportunity to use my calculator instead, I'm going to use it. So I'm going to go to stat. Does it say use the... No. So I'm going to, what is that? A and yes, confused. So what do I have? I had 414 out of 781. Now I want a 95% confidence level, right? Yeah. So if I go back to, I think sometimes it kind of helps to do this, to get split screen when I'm using my calculator. That's something I really should ask you guys about. All right, that should work. Let me see if I can. For some reason, that doesn't seem as sharp to me today. All right. So it says round your answer to 3 decimal places. So I would have 0.495 up to 0.565. Or we could think of this as 49.5% up to 56.5%. Be sure to report the margin of error. Well, guys, the margin of error is going to be easy. It's going to be the big number minus the small number divided by 2. So our margin of error is 3.5%. All right. Now I ask you to interpret right here, and this will be on your test, promise you. The interpretation of this is a 0.95 probability that this interval contains the percentage of adult Americans who agree with the recent Supreme Court decision. All right, making the assumption that this is a reasonable estimate of the proportion of adult Americans who agree that same-sex marriage should be legalized, how large a sample size for a future study is required to estimate the fraction of adult Americans who agree that same-sex marriage should be with a 95% confidence interval, error of at most 0.025. Let's use our formula. We saw in a previous video. Right? Okay, so let's just put in the information that we have in our problem. We know the p hat is 0.53. 1 minus p hat, if you don't know that, can't do the mental arithmetic, that's fine. Use your calculator, but it's 0.47. The desired margin of error is 0.025. The Z critical that goes with the 95% confidence is 1.96. And we square that. So let's come over in our calculator. So I'm just going to go straight on. I'm going to do the 0.53 times 0.47 divided by 0.025 divided by 1.96. Square that and hit enter. Round up, 1532. Guys, it's that easy. I know some of you feel like that you've lost your confidence in some of this, and you feel like you've got to go, get help on everything. You don't need to, guys. I'm making the handouts in the videos more like what we do, or what you do in the homework assignments, and more like what you're going to see on your exam, because the tutors can't come with you on the exam, so don't use them too much as a crutch, because that's instant gratification. That gets your problem solved quickly. but I don't think it has a long-term advantage for you really learning anything. Because what you end up doing is you end up just being able to do problems with your tutor sitting there. Guys, you got to do this on your own to a certain extent. All right, number 2, another controversial issue in recent news pertains to the displaying or flying of the Confederate flag in public places. In a recent survey conducted by Huffington Post, 1,011 adult Americans. So that's our sample size. Were asked if they supported displaying the Confederate flag in public places. Of those who were sampled, 243. So that's my X value, 243. Said they supported displaying the Confederate flag in public places, but only 192. So I actually have another, depending on what I'm actually wanting to focus on. So only 192 said they supported flying the Confederate flag on a government building. So there is a big difference. You know, if a local business wants to fly a Confederate flag, then it may be argued that they should be able to do so because they're opening their business with the intent of making a profit. And by flying the flag, I'm sure that there's going to be a certain group of people that will be attracted to that restaurant because they share a similar belief. There will be another group of people who will see the Confederate flag and quite possibly see it as a group of people who own a business who are racist. There seems to be that connotation with the Confederate flag for some people, and not attend, not go to that restaurant, completely abandon it. So the person has, in my opinion, they have the right to fly that flag if they want, and we have the right to choose whether or not we eat or support that business. Now, I have pretty strong feelings about this one, and again, I'm not going to tell you the way I feel, but I have pretty strong feelings about this. 192, which is less than 243, say that flying the flag on a government building, state-supported, that they support that. So less people, more people feel that a public place. So anyway, calculate and interpret the 95% confidence interval for the proportion of adult Americans who support flying the flag on government buildings. So guys, we need to focus on the 192. So I'm going to use this calculator for that. So again, let me see if I can get this where it's clearer. Maybe. I don't know. All right. One thing about it, I can sure get to the 1 prob Z interval here quicker. So, guys, we had what, 192 out of the 1,011 that were sampled, and 95% inch. So, all right, gang. So we want to I want to report this one as a percentage. Well, report it the way that your online course management system asks you to report it. But they probably say 3 places. So if they did, this would be 0.166, and this would be 0.214. But if they ask you to present it as a percentage, it would be 16.6%. Up to 21.4%. All right, so that would be calculated. Now we need to interpret it. So the interpretation, there's a 0.95 probability this interval contains the percentage of adult Americans who support flying the Confederate flag on government buildings. Margin of error, guys, y'all should be really good at that. Big number minus the small number. Divided by 2. So the margin of error is plus or minus 2.4%. In these margin of errors by CNN, Huffington Post, and different, even Rasmussen, it seems like that they seek to find margin of errors somewhere at 3 or below. So 2, 2.5, 3. They try to get a sample size big enough for that. So calculate and interpret the 95% confidence interval for the proportion of adult Americans who support displaying the Confederate flag in public places. Well, guys, for that we need to focus on the number of 243. So same thing. So the only thing we really need to change is just the 243. So let's say that this, was something that we did on Hawks, and they wanted presented to 3 places. So what would that be? 0.267. So that's the way that you would present that if they ask you to present it from 3 places. Now, they give you something else here. They give you this p hat of 0.240. Where does that come from? The 0.240356. Well, I mean, think it through. That's just what? Our 243 divided by 1,011. That's just our p hat. That's our count over our total. So, guys, back here, if we want the margin of error, big number minus the small number divided by 2. So 0.0265. All right. Or if you think like me more in terms of percentages, that'd be plus or minus 2.65%. So the interpretation here is a 0.95 probability, this interval, 21.4% to 26.7%, contains the proportion of all adult Americans who support displaying the Confederate flag in public places. Search the internet to find an example of the media inappropriately reporting the results of a study. Well, I'll tell you what, this should be easy. They do it all the time. So you can kind of at your leisure just about type in anything. So let's go to Google. That's the search engine I use. And just type in percent of people who are gay. Okay, here's one from 2014. Whoa, there's one from May 2015. Gallup poll. Americans greatly overestimate percent gay lesbian. Well, this really doesn't give you much of anything. Who are left-handed? All right, here's a study. I'll guarantee you to screw it up. Representing only 10% of the general human population, left-handers. Researchers now report a high degree of cooperation, the rarity of left-handed. Doesn't really say how the study was collected. Well, I don't believe it. Blue eyes. Well, guys, I don't believe any of this stuff. Really what I do. It says a 2002 study. Let's see. Kind of looks like my eyes, actually. Uh, let's see what the study that they're talking about. Uh, yeah, green. I don't care about all that. I want the study. Well, I'm crashing and burning here. Um, well, shoot. Usually I have no problem whatsoever finding, let's do CNN report, survey, eye color. See if they get into anything like that. Kids who sip alcohol are more likely to drink. Duh. Uh, let's see, report percentage of voters who will vote for Jeb Bush. All right, let's see what they do here. They're going to screw this up big time, I guarantee you. CNN politics. If you want to find some uh, really distorted surveys, look at these things. All right, let's see what they got to say here. The complete poll. This should be fun. So Bush stands at 19%, up from 13%. Now we're convinced because, let me see if I can get rid of. We're convinced from this that that must be true. So this is 19%. So his best showing in a polling. Wow, that actually is a correct statement. Best in a polling. Um, all right, guys. I'll tell you what. I've got something to do here in about 5 minutes. Take a look at this. See what you think. We'll talk about it more. Take care.